All right, well, here's an example, a couple examples of how to graph an equation when it's in vertex form. And these are quadratic equations, and vertex form essentially means where the graph, where's the vertex? It's in vertex form because it explicitly tells us where the vertex is. The only tricky part about it is the x portion of the vertex. We're going to talk about that right now. So notice how it says x minus 2 inside the parenthesis. So in this form, the vertex, the x portion of the vertex, is actually within the parenthesis. Now, we actually don't write negative 2, we write positive 2. Just kind of how, like, if we were to factor this, and we'd say x minus 2 equals 0, in order to find out what x is, we add 2 to both sides and get x equals 2. So in my vertex, x does equal 2. The y part of my vertex is on the outside, which we call k, and that's positive 4, so we just write positive 4. So for my vertex, it's the opposite of what's with x inside the parentheses, so negative 2 becomes positive 2, and whatever's on the outside, whatever constant it is, that's what gets written. So it's 2 comma 4. So we'll go ahead and plot that point there in my graph. Now, another thing I like to see is, okay, well, usually we can tell how, if it opens up or down, if my vertex is at the minimum or maximum, or how fat or skinny my graph is based on A. And A is the number in front of the parentheses. Now, I just wrote in a 1 because there was no number there, but there's always an implied invisible 1. So 1 means it's positive, so it's going to go up, and it's going to look fairly normal. So I'll go ahead and write that. So that's what a parabola looks like. Now, what do you notice about this parabola? It doesn't cross the x-axis. So if I wanted to solve for x, I'm not going to get real numbers. I'm going to get imaginary numbers. So I'm not even going to bother trying to find the x-intercepts because I know that there won't be any real x-intercepts because they'll be imaginary numbers. But what I do want to find is the y-intercept. And so when we find the x-intercepts, or the roots, or the solutions, we plug in 0 for y, or f of x. In this case, we're going to plug in 0 for x to find the y-intercept. So that's what I'm going to write up on the top. Y equals 0. You plug in 0 for x, minus 2 squared plus 4. Again, that y is going to equal 0 minus 2 is negative 2. Negative 2 squared is 4. And then 4 times 1 is 4. 4 plus 4 equals 8. So my x-intercept is pretty good where I drew my graph, if I do say so myself, at 8. Now, let's go and take a look at another example here, number 8 on our homework tonight. So, again, this is in vertex form. I know that because I have a binomial squared in there. The x part of my vertex is with the parentheses, so it says plus 3, but I know that my vertex is actually negative 3. And the y part of my vertex is on the outside, negative 4. So my vertex is at negative 3, negative 4, down there in the bottom. Next thing I'm going to look at is 2 in front of the parentheses. That's A. And 2 means it's positive, meaning my parabola is going up. My vertex is at the minimum. And it's going to be a little skinnier than usual. Okay, it's going to be a little skinnier than usual. But what else do I notice? I notice that my graph actually will cross the x-axis. So when I solve for x, meaning plugging in 0 for y, I'm actually going to get real solutions. Let's go ahead and do that. So 0 equals 2 times x plus 3 squared minus 4. So in order to get x by itself, we have to do a little bit of unwrapping here. First thing I need to do, get rid of that 4, so adding 4 to both sides will give me 4 equals 2 x plus 3 squared. Now we have to get rid of that 2 in front, so we divide by 2 on both sides. And we're going to get 2 equals x plus 3 squared. To get rid of a square, we square root both sides. But remember, if I write the square root into the problem, that means it could be both plus and minus the square root of 2 equals x plus 3. Final step to get x by itself, subtract 3. And I'm going to get negative 3 plus or minus the square root of 2 equals x. So this looks like one answer, but actually it's 2 answers because the plus minus sign means I have 2 different solutions. So I have negative 3 plus square root of 2, and I have negative 3 minus the square root of 2. So at this point, if you really wanted to graph this, you would actually need to crunch these numbers. So the square root of 2 works out to be about 1.1 or 1.2. Okay, so if you were to actually subtract negative 3 plus the square root of 2, you would get negative 1.6. So As you can see there on my graph, it sort of crosses there. It's close. I mean, I did a rough sketch, but that's pretty good. All right, and the negative 3 minus the square root of 2 is actually going to give us negative 4.4. And I did a pretty good job there too. So those are my two x-intercepts right there. And so I did a pretty good job sketching that graph. Now, obviously, if you find the x-intercepts, it'd be best to make sure your parabola, you can erase it and redraw your graph. But that is how you do a rough graph of parabola when it's in vertex form.